Last class we have studied about energy stored in capacitor. So in this class we will take some problem based on energy stored in the capacitor. Take down this problem. Find the total energy stored in the capacitors in the given network. Take down the network. One microfarad, 2 microfarad, 2 microfarad, this is also 2 microfarad, and we have 1 microfarad, we have another capacitor over here, that is again 2 microfarad. And the whole combination is connected to a 6-volt battery. Find the total energy stored in the capacitors in the given network. So we need to find out total energy stored. For that reason, first we need to find out what is the equivalent capacitance of this network. So this is the total network. First find out what is the equivalent capacitance. We can write here the total energy stored in the capacitors is U equal to half Cb square, half C equivalent into V square, where C equivalent is the equivalent capacitance of the given network. So first let us find out C equivalent. To find C equivalent, equivalent capacitance of the network. To find equivalent capacitance, so I will draw the network of capacitors once again here. This is the network. And we need to find out with respect to these two terminals. So all these capacitors values are in microfarad. 1 microfarad, 2 microfarad, 2 microfarad, 1 microfarad, and then 2 microfarad. Now if we look carefully, here 2 microfarad and 2 microfarad are connected in series. So this 2 microfarad and 2 microfarad, so these are connected in series. So this combination 2 microfarad 2 microfarad, that will give us one single capacitor of value 1 microfarad, because 2 microfarad is 2 into 2 divided by 2 plus 2, that is 1 microfarad. So this will now reduce into 6 volt, one microfarad, and then again we have 1 microfarad here, the equivalent here is now 1 microfarad. This again microfarad. Now carefully look, we can see that this 1 microfarad and 1 microfarad are in parallel. So this is in parallel. To find out equivalent of these two, we need to add them. So 1 plus 1 will give us value of 2. So this will now reduce into 6 volt, one microfarad, two microfarad, and parallel combination of 1 micro and 1 micro, that will give us 2 microfarad. Now again 2 microfarad and 2 microfarad are in series. So this is in series now. That will again give us 1 microfarad. So finally what is C equivalent? 6 volt, one microfarad, and again 2 and 2 in series will give us 1 microfarad. So the equivalent capacitance is 1 plus 1, which is equal to 2 microfarad. So net capacitance or equivalent capacitance is equal to 1 microfarad plus 1 microfarad equal to 2 microfarad. 2, 1 plus 1, those are in microfarad, so this will be 2 microfarad. Net capacitance is 1 microfarad plus 1 microfarad equal to 2 microfarad. Now the net energy stored in the network will be given by, we can write here, net energy stored is equal to half C equivalent into V squared. So it is equal to half into C equivalent is 2 micro, 2 into 10 to the power minus 6, V square, V is 6 square. So this is equal to 2 and 2 will get cancelled. 6 6 are 36 into 10 to the power minus 6 joules, or this is equal to 36 microjoules. So the total energy stored is equal to 36 microjoule. Microjoules. Total energy stored is 36 microjoules in the network. So the main thing here is to find out the equivalent capacitance of this network. So to find out that, we should know whether the capacitors are connected in series or parallel. So we need to carefully look into the network and reduce one by one slowly by checking whether the capacitors are connected in series or in parallel. Then once we find out the net capacitance, we can easily find out the net energy stored in the network.